Hello, I'm Jangyeon, undergraduate research student from Yeungnam University and a member of Humanics. Let's start the presentation. The presentation sequence is as follows. The bodybuilding weight training method is divided into 3 types according to the configuration of the exercise equipment. Free weight that can perform a variety of exercise events, consisting of only a barbell, a dumbbell, and a disc. And Smith machine that conducts exercise in free weight only on one vertical path due to the restraint of the frame, and machine with a fixed exercise path for one exercise event. The cons and pros of each type are as follows. As a result of considering several papers, although free weight is relatively difficult, it produces the most efficient muscle hypertrophy and muscle strengthening results compared to others. In addition, anyone can perform the exercise according to their own physical differences. For these reasons, free weight is evaluated as the most ideal method. Now, I will explain the research I am doing in earnest. Currently, a fitness boom is taking place worldwide led by MZ generation, and now it is affecting our lives as a culture. In addition, this trend has led to a demand for a more scientific and action exercise method. As a result, several digital weighting machines are being distributed in the market. I also started the research because I wanted to develop an all-in-one digital weighting machine according to this trend. Digital weighting machines, which is currently distributed in the market, are largely divided into wire type and Smith machine type. The wire type is the shape in which the arm protrudes from the device. After connecting the wire to the end of the arm, the pipe imposes the load on the user in the form of tension. Tonal products from tonal system is the representative product of the type, and Smith machine type is a form that simply converts the medium of load application from weight to actuator output. And the Olympic sewing machine is the representative product. Each type has the following characteristics. However, existing products have a few problems. First, in the case of the wire type, the direction of the output load is not constant due to the flexibility of tension. This creates a sense of alienation for users who are accustomed to traditional weight. In order to improve the problem of the existing products analyzed above, I would like to develop a digital weighting machine that can freely move with the output load always facing the ground uniformly. The device to be developed should be capable of delicate load control, ensure user safety at all times, and be able to exercise alone. The equipment being developed to meet these requirements is the lever machine. I will explain the hardware configuration of the lever machine. Our product consists of a digital load generator with a rotary motor and a low reduction gearboxes. At this time, the motor control was implemented as an open-loop current control based on Quasi-Direct drive actuation. The motor was composed of 1.6 kilowatt class T motor, R100 kV90 product, and the drive was composed ASCON 7010 product with the performance downgrading for safety. Also, the gear ratio is 4:1. In the future, we plan to upgrade the high power drive for higher load output and conduct research. The following is the description description of the hardware configuration that enables the user to operate 6 degrees of freedom, even while holding a barbell constrained to the frame. At this time, 6 degrees of freedom means translation and rotation of 3 axes in space. As shown in the video on the top right, we named this module an infinite degree of freedom module, and it is configured and combined as shown in the figure on the right. Now I will introduce the basic user feedback functions of the currently implemented level machine. I have implemented the counting function and posture running function. These functions are implemented by processing data from incremental encoders coupled to the bus gearboxes. This is the basic operation video. You can see counting the numbers of times and posture analysis and loading in real time. The following is an experiment to see how well the exercise on our machine tracks the actual free weights. As shown on the left, using EMG sensor barbell curls of 16 kg first level were performed with 2 environment settings. As a result of the experiment, when looking at the biceps activity per pulse in the free weight and level machine, the maximum value and minimum values are almost identical, and it can be seen that the level machine maintains high energy for a longer period of time. In this way, we see the possibility that performing exercise on the level machine can provide a similar or even better thinking effect than free weight. From now on, I will explain about future work. The motor driver we have configured from the QDD method, since this method is basically an open loop controller. A hardware setting that guarantees continuous reliability is required. Among them, we want to maximize QDD performance by designing a new concept reducer and applying it to level machine, away from the mechanical reducer that inevitably has a large volume and gradual performance degradation. By applying the Pascal principle, we can implement this. In the principle, we can expect deceleration effect by using the cross-sectional area ratio of the input and output terminals. If we bring the aforementioned contents to rotational dimension, we expect to be able to amplify the torque in the rotary motor as well. To implement this, we are considering using a magnetic controller, and we are thinking about how to implement changes in input and output cross-sectional area. In hardware, if the product's development is completed, it will be able to be innovatively applied to various fields by the compactly combining with a rotary motor. Thank you for listening so far. If you have any question, please feel free to ask.
Is there any question, comment? Okay, since lunch is ready, we close this session, and please enjoy the rest of the conference in Jeju. Okay, thank you.